Gravimetric analysis is a fundamental quantitative analysis that measures mass. It involves the conversion of an analyte, the component of a sample that is the subject of the analysis, into a substance with a known composition, such as a pure compound, that can be weighed. The main concept is based on mass conversion and stoichiometric relationships. By converting the analyte into a precipitate, the mass of the precipitate can be used to calculate the mass of the original analyte using molar masses, providing a consistent measure of elemental concentration in a variety of fields including material science. The specific goal of this experiment is to determine calcium in an unknown sample using gravimetry by precipitating it as calcium oxalate monohydrate. Previous studies have shown that successful precipitate isolation emphasized on strict control of reaction conditions. Specifically, precipitation must occur slowly and at high temperatures to ensure the formation of pure crystals that are easy to filter. Washing, drying, and weighing are all necessary stages to accurately calculate the percent mass of calcium in the original sample. This procedure evaluates the accuracy of gravimetric methods for measuring metal ions in complex solutions. The objective of the experiment is to determine the unknown mass of calcium in the sample using stoichiometric principles and a method for transforming the calcium analyte into a quantifiable oxalate salt. In hypothesis, strict control over the precipitation, filtration, and drying steps will result in a final mass of calcium oxalate monohydrate with calculated calcium percentage that falls within the suitable range of standard analytical uncertainty.
Firstly, weigh the solid unknown between 1.2 to 1.5 grams. In this experiment, we use 1.338 gram of the solid unknown. After weighing, transfer the unknown into the 250 ml beaker. Measure 30 ml of distilled water and 12 ml of 3 molar hydrochloric acid and adding it to the beaker respectively to dissolve the solid unknown. Stir it with glass stirring rod for a few minutes. Let it cool off to the room temperature. Quantitatively transfer it to a 100 ml volumetric flask by washing the beaker 3 times with distilled water. Use small portion of the unknown solution to rinse a 25 ml transfer pipette and discard the washings. Transfer 25 ml of unknown solution to each of 3 250 ml beaker using the transfer pipette. Measure 75 ml of 0.1 molar hydrochloric acid and add it to the beaker to dilute each of the unknown solution. Add 5 drops of methyl red indicator solution to each beaker. Measure 25 ml of ammonium oxalate solution and add it to each beaker while stirring with glass rod. Remove the rod and rinse it into the beaker. Add 15 grams of solid urea to each sample. Cover it with the wash glass and boil gently until the indicator turns yellow. Weigh 3 different filter paper and wash glass for each sample while waiting. Next step, filter each hot solution through a wake funnel using suction. Add 3 ml of ice cold water to the beaker to transfer remaining solid to the funnel. Repeat until all precipitate has been transferred. Transfer the filter paper onto the wash glass and dry it in the oven. After drying, weigh it to obtain the mass of the precipitate.
Discussion. Based on the 3 experimental determination of calcium, the percent of calcium in the unknown solid is 0.69%, 0.68%, and 0.91%. The value 0.91% on experiment 3 can be considered an outlier because it has a noticeable deviation between experiment 1 and 2. The mean percent of calcium in the unknown solid is 0.74%. The value of standard deviation percent of calcium in unknown solid is 0.15%, while the relative standard deviation is 20.27%. Source of error. Number 1 is loss of precipitate during transfers the solid from the beaker to filter funnel. Number 2, incomplete drying the precipitate. And lastly, number 3 is overheating or decomposition of precipitate. Ways to overcome. Make sure to rinse the beaker multiple times to ensure the quantitative transfer. Number 2, use a rubber policeman to scrub all the remaining solid. Number 3, dry the precipitate until constant mass is achieved. Number 4, maintain the temperature 105 degrees Celsius while heating the precipitate. Conclusion. In this experiment, calcium in the unknown sample was successfully determined using a gravimetric method based on the precipitation of calcium oxalate monohydrate, which is 0.74%.